Okay, we're going to go over something called first differences, and we need to talk about how this relates to what we've been doing. First differences is a process to help us tell if something has a linear relationship. So I have two sets of data here, okay? And luckily they've been organized into our independent and our dependent variables, so our x and our y, okay? And they're in order, okay? Now, in order to apply the process of first differences, which we'll talk about what it is in a minute, we have to check a few things first. So, for instance, on the x-axis, I have to make sure everything is changing by the same amount, okay? And what happens, or in this case, what does everything have to be changing by? Okay. This is very important that this process is happening. Okay? In order for this to happen, we can then check first differences. If it's not increasing or decreasing by the same number, then we can't use this process. You might find a question like that on your test where it's not increasing, so this is redundant. Now, first differences is the process of finding the difference. What operation is difference?
Subtraction.
Yeah, so the subtraction between two of the y values. Okay, so what we usually do is we start, if we have the x is increasing, we kind of start at the bottom. Okay, and what we're going to do is we're going to find 18, the difference between 18 and 15. And what is it?
3.
Good, it's positive 3. Okay, the positive and negatives are actually very important because they're going to help us build an equation. The next one, we do 15 subtract 12. 3. Ah, very good. So you've already started to notice that the pattern is 3. Okay. So what this means, if our first differences, and what I mean by first differences is the first time we subtract our y values, if they're all the same value, that means we have a linear relationship. Okay. So this is linear. We do know that. From this, we can actually build our equation. Do you guys remember the basis? Y equals what? Yeah? Very good. This is going to be very important through all of grade 9 now. Okay? And what this is our rate of change, especially if our x's are going up by 1. Okay? In this case, it's going up by 1, so we can check this. Our differences are the value of 3. This is actually our m value. Okay? So because we found our differences to be equal to positive 3, okay, so because it's equal to positive 3, our m value is equal to positive 3. So I can replace m with the value of positive 3. And what about my b? What does b stand for? The y-intercept. And the y-intercept occurs when x is equal to what value? This is hard without a graph. It's tough. So I'm gonna just sketch a rough graph very quickly in your right, Grant. When I'm crossing, this is our y-axis. When I cross it, maybe that value is 3. What is our x value on that line? 0. So a y-intercept is when x is equal to what value? 0. So these are technically all coordinates. And if we were to plot them all, we'd find we have a linear relationship. Okay, everything's going up by 3. We'd end up with a positive, because it's positive 3, relationship. And our y-intercept, when x is 0, y happens to be 0. So we can replace our b in the equation with the value of 0. Do I need to write in 0 when I write it in this equation? So how can I write this simpler? 3x. What type of variation is this? All right. This is direct variation. Okay? It is direct variation because our y-intercept is 0. Let's go up to our second example. We'll go through a couple more. What's our first check? What do I have to make sure is happening in order to do first differences? Yeah, we've got to make sure our x's are increasing by the same value. It doesn't have to be 1. In this case, it, again, happens to be 1. But I want you to make sure that they are increasing by the same amount every time. Okay. Now that we've done that, we're going to take our most far down, or in our case, our largest y value here, where our x is farthest along, and we'll subtract. So I have 1 subtract 3 equals negative 2. Okay. What is 3 subtract 5? 5 subtract 7. 7 subtract 9. 9 subtract 11. And 11 subtract 13. Good. So is this linear? Yes, this is linear. Okay, all of the first differences are the same. What is their value? Negative 2. So if I was to put it into y equals mx plus b, what is my... Very good, though. So our m is which value? Okay, so we know we're going to replace m with our negative 2. So we're building our equation. Y equals negative 2x. And our b, what is our b? When x is 0, what is the y value? 13. So that means our b value is 13. So it becomes plus 13. I'll write this all in black so it kind of looks like a final answer here. That's right. This is partial variation. Okay. So we have 2 more examples I would like to look at to see if we've applied what we've just talked about. So in this relationship, is this a linear relationship? What's it increasing by? 2. So is it linear?
Yes.
It is? No.
How?
Why is it not linear? That's right. If you look at our x values, this increases by 4, 2, 4, 2, 4, 2. So this is constantly changing, which means we can't really apply our first differences. Now, it doesn't mean it's not linear. I might have to plot these to check, but I can tell you right now that I know for a fact these aren't linear, because these are not changing by the same amount, and these are. Okay? And this is not a concept we technically have to know, but this is going to mean this is not linear. So in order to do first differences, we can't do our first differences here, okay? We can't do first diff, because this is not increasing by the same amount. Now, let's go to the second example. We got to go by our check. Are these increasing by the same amount?
Yes.
What is it changing by?
4.
That's right. Positive 4 every single time. Excellent. So we can do our first differences. So let's do the first differences here. We start at the bottom.
1. Negative 1.
What does it equal?
1.
Negative 1. And as we go up? Good. So, now this is a very tough idea. First of all, is this linear? Yeah, it is. It followed our pattern. Our x's all went up by the constant amount, therefore our y's go up by a constant amount. It is linear. Now, to build my equation, and this is a very difficult part, okay? Y equals mx plus b. If you guys remember in our other example, I said that our first differences are our m if x is increasing by 1. And it was increasing by 1 in all of these cases. Okay? In this one here, what is our x increasing by? 4. So is this technically our m? Maybe. Okay? And I'm going to let you know, because we don't know yet. It actually isn't. But we can find our m. Okay? I just didn't give you the extra step in the other ones, because there's no reason to apply it. Actually, to find your m, find out what our y is changing by divided by what our x is changing by. Have you guys seen that before? Yeah, we've talked about it. So, what is our y changing by? And what is our x changing by? Positive 4. So our m is negative 1 over 4. Now, why didn't I have to do that in these ones here? Yeah, so what does that mean? When change in y over change in x, let's talk about it. What was our change in y in the first example? 3. And what was our change in x? 1. So what's 3 divided by 1? 3. So when it's 1, we don't have to worry about dividing, because anything divided by 1 is that value. Okay? So that was our first difference. In this one, because it wasn't technically by that, we had to divide. And that's a tough idea. And if you can get that, that's probably going to be a nice bonus mark on a test. Okay? So what is our m? Negative 1 over 4. And what is our y-intercept?
6.
That's right. It's when x is equal to 0. So our y-intercept is positive 6. And what type of variation is this? Let's say partial. T-I-A-L. And just to put a note on the bottom one, was this linear?
Maybe.
Non-linear. I told you guys that it technically was. Okay. So that's everything we've done today.